Hey, welcome back everybody. Today we're going to make a little walkthrough video for the Gerbil Space Program. The Gerbil Space Program is one of our first attempts at actually creating a full-blown program that uses custom user-defined classes. So the program solution, let's go ahead and run that solution really quick. So we run that solution, we get these little gerbils. The first thing it does is it gives us a list of the available launchers, the cannon, the catapult, and the slingshot. You can type in any one of those that you want. So this is a good opportunity to use some force correct input because if they enter something that's not there or they spell it wrong, it's going to cause you some issues later. So take a little bit of time to build that loop in to make sure that your user input is correct. After you enter the launcher, notice that the launcher is going to appear in the lower left-hand corner of the window, and kind of pay attention to the relative size of the launcher. It looks like it's just going to take up to about that first little grass plane right there. That's important because the actual launcher image is about the entire size of the window. So that means we're going to have to do some positioning and some scaling. The little gerbil guys, they're created automatically and they always appear there. So we're not going to have to take care of that piece. So then we enter one of the available launchers. So let's go the soccer ball. And again, we want to make sure we're using that force correct input there. When we hit enter, we should see the soccer ball. It launches across the screen. And we're not going to see it because it went all the way over the edge. But eventually, when that soccer ball hits the ground, somewhere way off the edge of our screen, it's going to register that it's on the ground. The program's going to terminate, and it's going to tell us the distance that it traveled before landing. So the input in there is going to be the launcher selection using some force correct input, and the projectile selection again using force correct input. The output is the visual depiction of the launch and the distance traveled at the end. So let's go through these requirements, and then we're going to come back to them. We're going to use this as our checklist. We're going to create a launcher in the launcher.py that has an init method that creates the sprite and power attributes based on parameters. So we're going to take some input inside the parentheses. Create a projectile class in projectile.py that has an init method that creates a sprite, weight, and diameter attributes. The init method should create a sprite attribute that starts invisible. Then we need to create a launch method in projectile.py that takes a launcher instance as an additional parameter, and it calculates and sets the projectile speed as well as making it visible. Then we create a fly method that calls another private method to calculate movement and updates projectiles on the ground. So really the only thing the fly is going to do is it's going to apply gravity and it's going to apply air resistance. And then it's going to test to see if the projectile has hit the ground. It's going to set this on ground. So that's our first clue there, that our projectile also needs to know whether or not it's on the ground. So that should have been really specified up here in the requirements for a init, but we got it right there. And then we get some formulas that say the scale attribute, the horizontal and vertical launch speeds, how gravity is applied, and how air resistance. And we'll go through those when we create those two private methods here in a minute. So let's take a look at the main part of the program, the Gerbil Space Program. Okay, so let's start there. And we notice that a lot of the window and background stuff is set up for us. The gerbil section here is going to take care of those little gerbil scientists. And then it finishes the frame, so it draws that initial background for us. Then we have this launcher selection, and the launcher selection is already built in. So that input there is already done. We don't even have to do that. So the way that it does that is it reads that os.path.join from launchers CSV. So there's a CSV file that it's going to read from, and it's going to make a list out of those and present those to the user. So that's great. That's going to actually handle the user's input for us. Then we get into the launcher instance, and this is where they're going to create the launcher for the first time. Right here on line 49, we see the capital L launcher. So in our launcher class init, we need to make sure that our parameters match in this order. So the first thing in our init for launcher is going to be self. Then we're going to get some image name. Notice that's not a sprite. but it's not sending us the sprite. It's sending us the .jpeg or .png image location. So we are going to have to create the sprite in our other file, but we'll know what the image is. And then it's going to send us this launcher dictionary entry for power that's an integer. So we need to be able to handle a string for the file name and an integer for the power. Okay. Then we set our projectile selection, and again, it's going to do all of that input stuff for us. So we don't even have to do that. That's great. Then it creates the projectile on line 71. We look for that capital P projectile. That's what's calling the projectile class's init method. So again, our parameters for the init method are going to be self, comma, an string for an image name, an integer that represents the weight of the projectile, an integer that represents the diameter, and an object that is the launcher. And that object is extremely important when we create that projectile, because we need to know where the launcher is located so we can put the projectile on top of it and not just try to guess. So if the launcher moves, we can position the projectile relative to the launcher if we know where that launcher is. So that's why they're passing that launcher. Okay, then we prep the launch, so they're doing the timing for us. They set the animation rate, they start time. So there's a lot of good stuff in this program when you guys are working on your code your owns or you're working on some more complex program. This is a great reference program. The code that's already here for you has some reading from a CSV, using dictionaries, creating and using timers. All of that's written for you. This is a great place to look as a reference. So put that down. Hey, go back to my Gerbil space program and check that out. While window is running, we're getting the timer. So we had a start time up here. We have now, and then we look for the elapsed time. Now minus start. So we're looking at 500. So remember, the program duration is in milliseconds. So 500 would be half a second. So if half a second has gone by and we have not launched yet, then we're going to set the image animation rate to 0, and we're going to call this launch method from the projectile. Remember, the launch method puts it at the edge of the launcher, makes it visible, and starts the vertical and horizontal speed to that initial value. Then we say if it's in the air, if it has been launched, then keep applying the fly method. And when the fly method is going to apply gravity, always forcing the projectile down, and it's going to apply air resistance to counter the X speed so that it's going to look like a nice physics parabolic flight. And then we say if that projectile is on the ground, set the running to false, and then our final output is just to get the distance, which is the x divided by 10. So the distance is already done for us. So much of this code is already done for us. You just need to take a few minutes to go through it and really absorb what is being given to you. Okay, so now we're going to go to the launcher itself, because that's the easy one, and we're going to use our checklist for our requirements. Here's a checklist. Create an init method. Okay, so launcher class. What class is needed to create a class that represents a launcher? So here we're going to type class launcher. Beautiful. Okay, then inside that class launcher, we're going to create the init method. So define, just like any other method, _init. And we always give it self. And then we look at our assignment window, and it doesn't seem to take any more parameters. We can double check that in the Gerbil space program when our launcher was created. Oh, see, there's the parameters. So if we don't know, always go back and check and see how it's used. We need the string for the image and the int for power, so we can do that. So we got self, image file, and power. All right. It says create the sprite and power attributes. Well, the power is nice and easy. We just have self.power equals power. The sprite, remember the sprite needs three things. It needs an image name and it needs an X and a Y. So the X is going to be at the 0. That's launcher always up here at the left edge, but it's going to be at the bottom of the window. Well, we're not getting the window as an environment variable, but we can find the window by looking at the grassy cliff edge file. So we know that the window is 1018 pixels wide, 573 pixels tall. So this bottom pixel is 573. If we back up the height of the launcher, we should position it right there. Okay, so that out again for you. Give you a little more room here. Self.power. And then create the sprite. Self.sprite equals. Now notice here I'm using S as a lowercase letter because I'm not using the sprite constructor here, but a variable or the attribute of a launcher. So here I'll use tsapp.sprite with a capital S. I'm using the sprite constructor, and then I'm going to pass it an image file, which somebody gave to me. And then for now, I'm just going to put it at 0, 0. Because I don't know how tall it is yet until it's been created. So I can't do self.sprite.height until I've actually created it. So now I can do self.sprite.y equals 573, which was the height of the window, minus self.sprite. That should back that up. Okay. Now, I need to scale that launcher. So we can actually run the project now with a little bit of, see, it's going to break. So it cannot get projectile until projectile is created. So let's come back here to projectile, do class projectile paths. That should allow us to at least test. So I want a cannon. So we see the problem here is our cannon is ginormous. Okay, so we need to fix the size of the cannon. So we're going to need to scale that. So be careful when you scale things. If you position and then scale, then your positioning will be off. So the algorithm, anytime you're going to position images, is make the sprite, change its scale, then position it. So we'll do self.sprite.scale equals 0.2. So let's go down all the way down to 20% and see if that gets us close. Cannon. Okay, beautiful. Okay, so again, the X was positioned at 0 initially when it was first created, and then I scaled it so you can see that little hop over. That's exactly what happened. So I fixed the Y after the scale, but I never fixed the X, so I need to come in here and add another line, self.sprite.x, and reset that back to 0. And I'm going to test this with a few real quick, and then we're going to end this video for part 1, and we'll move on to part 2. So test yours, get caught up, slingshot, test it with a few different ones, make sure that scale is okay. You might even want to shrink it down just a little bit more, but I'm going to go ahead and run with 20%. All right.